right? So today, so we would like to interview Professor Mircea Mustaţă from University of Michigan. So before starting the interview, so let me briefly explain his background. So Professor Mircea Mustaţă was born in Romania, and he completed his PhD in UC Berkeley in 2001. And after that, so he achieved a Clay Research Fellowship. And then he joined the University of Michigan in 2004, right?
Yeah, correct.
And, yeah, he studied algebraic geometry, especially singularity of algebraic varieties. Okay, let's start the interview. So, okay, first question is, so how and when did you become interested in mathematics?
Well, so I guess it was in elementary school, maybe around 6th grade. Basically, again, at the time, mathematics was more like a set of puzzles, somehow try to solve. And at the time, it was popular to go to the math Olympiads. So I started going to the math Olympiads, and then you go to the math circles, and you have some very dedicated teachers who basically teach you various tricks in order to solve Olympiad-type problems. So that was fun, because basically you could meet other people with the same interests. Of course, the downside means maybe that you start treating math as some sort of competition, and I was not particularly good, so there were other kids much better than I was. So at some point it gets frustrating. But on the other hand, it's interesting. So the other downside is, again, that you don't see the real math. Maybe you just see more a set of tricks. On the other hand, at some point you go past that.
So at the time, so you were interested in something like a puzzle, so not like a linear algebra or calculus.
That's right. So those were more like, I mean, it was also some calculus, some, I guess, some geometry and some algebra, but basically at high school level, slowly. So basically I started like in 6th grade, and I kept going all through high school.
But at the time, so you already decided to go to math department, I mean, when you entered university?
No, that's a good question. So that was during communism, and at that time, if you finished the math at university, you just go to a small village to teach kids. So I didn't particularly want that, but fortunately when I was at the end of high school, actually, the regime changed. And then it looked much more promising. So I decided to actually, especially since I was not able to actually take exams in physics or other fields, I decided to go to math. So.
I see. And so you got a master's degree in Romania, and
yes.
Then you moved to...
And then I went to the US.
United States. And then, so when did you decide to become a mathematician?
Well, I guess slowly, so somehow, in some sense, it was not a real decision. Basically, you move slowly. Basically, that was the thing that I like to do. And then basically you want to spend time doing what you like to do. And I didn't really know what being a mathematician is about. Mostly I saw that, okay, maybe you spend time doing some research, but I had no idea what research meant. And I guess I imagined that you spend time teaching students. So, I mean, that sounded fun. So, but yeah, it took a while until I understood actually what it was about. So,
so moving to the United States is a kind of big decision, I think. At the time, so you don't, so...
Well, in some sense, it was kind of obvious, because at that time, almost everybody in Romania was going abroad for PhD studies. And somehow, I mean, looking back at it, I think it was very fortunate. I was very lucky that somehow I ended up where I ended up, and somehow that I worked with who I worked with. And it worked out well, but I had no idea. Basically, the point was that at the beginning, I didn't want to leave, but there was nobody else almost in my generation around. So...
I see. So then, so you moved to Berkeley, and so you got a PhD under the supervision of Professor David Eisenberg. I think David Eisenberg studied commutative algebra rather than birational geometry. So how did you get interested in birational geometry?
Well, so first of all, one small correction is that actually I went to Brandeis first. So David was still at Brandeis at the time. And after 1 year, actually, he moved to Berkeley and he took me with him.
I see. At the time, he was still in Brandeis.
So I spent 1 year at Brandeis. And I mean, the truth is that when I started, I was more interested in algebra. So basically, the first thing that I really started liking it was commutative algebra. So that was maybe like in my 3rd year as an undergraduate student. And slowly then I learned some algebraic geometry and I became more interested in geometric side. So that's why I wanted to go work with David, because somehow he's a commutative algebraist, but basically he works a lot with algebraic geometry. So in fact, when I was a graduate student at the beginning, I was more interested in more algebraic things like toric varieties, monomial ideals. And then somehow, just by pure luck, somehow I learned from David about a problem that was relating some algebraic objects called jet schemes to singularities. And so he had been working with Ed Frankel on questions they had. And so they brought me into it. And that's when I had to actually learn some stuff about singularities of higher dimensional varieties. And then slowly, basically I got interested. I think David ran a seminar on what was at that moment some draft version of Rob Lazarsfeld's multiplier ideals book. And I started liking it. It seemed like something that I enjoyed doing. But I still think that I'm basically an amateur in this birational geometry. So somehow I like it very much, but somehow I'm not really a professional. So there are people who really make a living out of it. Yeah, so.
Okay, then maybe let me change the question. So you already spent 1 month in our department. So have you ever noticed a difference between the math department in Japan and in the United States?
I see. That's a good question. So I'm not sure that I spent enough time in order to actually have a good idea. But maybe one thing that I noticed is that students tend to be a bit shyer than in the US. Somehow, I mean, for example, in the US, if you go and visit somewhere, usually students come and ask you various things and somehow strike a conversation. So here I've had it didn't happen so far. Maybe I hope it will happen, but maybe it was also my fault, but I should have been more upcoming. But yeah, so my impression is that there is a little bit of a distance, and somehow my encouragement, I think, for them would be to basically try to talk to people. So somehow, even if it's more senior people, so.
Oh, yeah. Yeah, so usually in Japan, so students call professor as sensei, so then it's more, for example, I guess in the United States, so some students call his supervisor by his first name, but in Japan, such kind of things never happen.
Unheard of. I see.
But even in US, so some cases, so
there are some exceptions.
There are some exceptions. So maybe Professor Corral. So
yes, I think so.
Yeah. Okay. Okay, then. So this is a final question. So could you give some advice to young people who wants to be mathematician?
Yeah, I'm not sure that I'm the right person to give advice. But I think my feeling is that somehow, there are a few things that nobody tells you when you start being a mathematician. So there are some good parts and bad parts about the job. Maybe to start with the bad things is maybe that, okay, there are periods of time when somehow nothing seems to work, and I think it's good to keep in mind that those hopefully pass, and somehow then you can actually prove theorems again. And on the good side, so for example, one thing that I didn't realize when I started was, what good opportunities you have to travel. So for example, I'm here now, so somehow, and the other thing is that it's really a collaborative effort. That somehow I think it's a good way to actually work with your friends, and somehow it's really not a competitive environment. And I think that's great. And the other advice is basically just, if you enjoy doing it, just keep doing it. It's fun. You get paid to do what you like to do, so why not?
Yeah, but so about the collaboration, so you have many collaborators, but how do you collaborate? So basically, so your collaboration start. Sometimes collaboration is done by the exchange of email, or you always start.
I think it depends. So I have collaborators that have been old friends for a long time, but sometimes yes, sometimes it's true. You start collaborating. You send an email to someone, and basically things develop. But really, collaborations arise, from many different ways. Sometimes you're at a conference and you start talking to somebody and there is some joint thing. But of course, I have old collaborators that I've been working with for a long time, and it's always a great joy somehow to work together. So.
I see. Yeah, maybe. So young people don't know that. So mathematicians collaborate so often.
I'm also always a bit struck. So when I started working with my advisor, I realized that I think it was only his first paper that was a single author paper. Everything else was actually a joint paper. So then I realized that actually, at least some people actually like to collaborate very much.
Okay, then thank you very much.
Okay, thank you very much.